Yeah, 'cause I'm a particle physicist, and I think my career in particle physics really began in 2012 when I spent a few months working at the Large Hadron Collider at CERN. Now, the Large Hadron Collider is a 27-kilometre tunnel under France and Switzerland. It's colder than outer space. It cost $13 billion. It's for smashing stuff together and seeing what happens. My job was to try and find a way to stop bits of dust falling from the pipe into the beam. I think they've sorted it out now. Actually, it was mainly drinking. Don't tell anyone, but the CERN summer student programme is best thought of as a free holiday that you pay for by making histograms. The only thing I really remember from that summer, there was a lot of tequila, the only thing I really remember is the hydrogen tank. The LHC accelerates protons to ludicrous energies, and all of these protons come from this small tank of hydrogen gas that just sits in a warehouse at the start of a sort of daisy chain of accelerators. You know, you can go and look at it, you can go up to it and touch it. It is not well guarded. And I just thought it was completely incredible that you take this like regular tank of hydrogen and then you ionize it, you accelerate it, and suddenly it discovers the Higgs boson. It's just a completely ordinary, boring gas. And then you pass it through some magnetic fields and suddenly thousands of scientists are struggling to understand what the fuck is going on. This story encapsulates science. The LHC is very sciencey and they throw excellent parties, but physics is just as much about the hydrogen tank and about how it's ionized and accelerated and about the superconducting magnets and about all the chairs at CERN and about the beer fridge and about the Alps. One of my bugbears is that in the eyes of the media, some things are more sciencey than other things. Brains are sciencey, stars are sciencey, the atoms in brains and stars are sciencey, but say tables are not sciencey. But the amazing thing about physics is that the atoms and the laws of physics inside your brain and inside a star and inside a table are the same. It's protons, neutrons and electrons in various configurations. So why do they behave so differently? Why doesn't the table shine? Why doesn't the table experience existential dread? And that is what physics is about. I wish the New Scientist would publish an article entitled 10 Key Differences Between a Supernova Explosion and a Fork. When I was a teenager, I was part of a gym. Obviously, I'm not anymore. Terrible idea. And the under-18s group at the gym was called Supernova. And their slogan was Supernova, definition, a bright young star. Now, this definition is 2/3 accurate, which at undergraduate level is a 2-1. So it's not bad. Supernova is actually the explosion at the end of a star's life. Now, anyone in the audience who speaks Latin and who isn't sufficiently in awe at my expertise as a theoretical physicist might be saying, but hang on a minute, supernova has new in the word, so what's going on there? One of the many things I hate about astronomers is that they've been going since the dawn of humanity. You don't need any equipment to do astronomy, you just look up. They've been going since the dawn of humanity and they've never updated the name of anything. And when a distant star explodes in a supernova, it appears like a bright new star in the sky. And hence we are stuck with a name that is explicitly wrong. I wish the New Scientist would publish an article called 10 Key Differences Between a Supernova and a Fork. But they aren't returning my calls, so I had to think of them. I had a sort of second order back reaction laugh there, and it was great. It's harder than I thought it would be. It's actually kind of a weird question. But I did not get where I am today by giving up on my arbitrary self-imposed challenges. So I wrote a list. 10 key differences between a supernova and a fork. 1. A supernova is in space, whereas most forks won't be for the foreseeable future. 2. A supernova lasts for a few weeks, but forks are forever. 3. A supernova produces a lot of neutrinos, but forks hardly any. Just an aside on neutrinos, for anyone who doesn't know, neutrinos are very light particles. There are billions of neutrinos streaming through you as we speak, billions every second. But we don't feel them because they hardly interact with anything. We actually think there are more particles yet to be discovered that just don't interact with what we think of as normal matter, the matter we're made of, so they're very hard to detect. The trouble with working in particle physics today is all the easy particles have been taken. Gone are the days when any old bloke with a particle collider could discover a fundamental new constituent of matter. No, particles yet to be discovered are the awkward ones. They're either so big we had to build 27 kilometres of collider to create them, or they simply don't interact with any of the contraptions we built in our increasingly frustrated attempts to discover them. I'm not bitter, it's going to be fine. Right, moving swiftly on. 4. A fork exhibits the Pauli exclusion principle through interactions of phonons and other quasi-particles, whereas a supernova exhibits the Pauli exclusion principle through electron and neutron degeneracy pressure. 5. Forks can be made of metal or wood or plastic, whereas a supernova is mainly made of star. 6. The plural of fork is definitely forks, whereas I don't really know whether it's 2 supernovas or 2 supernovae or 2 supernovae. 7. When I was younger, I never wanted to be a fork. I had an odd childhood. One unusual thing was that we had quite a sort of non-traditional parenting arrangement in that my mum was the main breadwinner and my dad did most of the childcare, which was great, but you know, gender stereotypes are very sneaky, they get everywhere. And one day I came home from nursery school and I said to my little brother Joshua, right, we're going to play mummies and daddies, and I'm the mummy, so I'll stay at home and clean the house, and you're the daddy, so you go out to work. And my mum heard this, and she wasn't happy. She said to me, but Francesca, that's not how it works in our house, is it? And I said, oh no, it's not. You go out to work, and daddy stays at home, and nobody cleans the house. Also, I wanted to be a supernova. Right, back to the list. 8. A supernova is a much more obvious manifestation of the second law of thermodynamics than a fork is. I love these, I get this sort of trickle while successive people understand the joke. So the second law of thermodynamics basically says that the amount of entropy or the amount of disorder in the universe always increases. Life itself can be seen as a fight against the second law of thermodynamics. We are not going to win. 9. A supernova has more gold in it than a fork, but this gold is much harder to access. 10. No one knows what happens if you put a fork in a microwave. Supernova. Have you paused at the last line? Bloody hell. Can we rewind, please? No one knows what happens if you put a supernova in a microwave.